participants on the other side who are visiting our campus for the first time. So I'll just take 2 to 3 minutes before I invite Dr. Richa to share the key findings of her report. So CSE was born in 1981 and it was founded by Anil Agarwal ji, who was a graduate from IIT Kanpur. So he, instead of going the normal way like every IITian, he thought of starting something to make environments a common man's agenda. So you can easily imagine back then in the 80s, somebody who was talking about environment used to be termed as pagal, right? And today, after almost 4 decades, there's nothing more relevant than environment or climate change or global warming or whichever way you put it, right? So it's basically research, capacity building, and advocacy is what we are known for, what we do best. If I put it in numbers, it's about 70% of our work is research. You have seen some of the glimpses of the kind of studies we do. Every report that we do, every report that we release has an implementation connect, has a policy connect, right? So this event is being streamed live. We are going to share our findings after we gather the inputs from all of you, all the esteemed speakers and panelists, and make a solid case and present it with evidences from the ground, which the report will talk about. I hope you already have received a copy that we have received of the report that we have released today, so that we get this agenda reflected in the policy. At the same time, the policymakers passes the directives for the implementers to focus on it. Sukanya, I need your help because the slides are not moving. So, so CSE has different units, or you can say different programs to deal with different facets of environment, as you can see it on the screen. I'll not get into the detail because everything that you have seen on the screen right from the beginning today till the end of the program tomorrow will be shared with you in soft copies. Okay, so that you will have time to refer to everything that I'm discussing right now. This is our main office in Delhi. This is the office that after Anilji started CSC in a 10 by 12 room in Greater Kailash. Now CSC has almost 200 people working in 3 different locations. So this is our second office, a smaller one, because we can't accommodate everyone in the Tughlakabad main office. So we had to take one office in Habitat Center. This office is also almost 35 years old. This is our campus where we are right now. It's called Anil Agarwal Environment Training Institute. And the reason why it's called a training institute is something that I'll explain in a minute. We also have our environmental monitoring lab. It's a state-of-the-art laboratory which is capable of doing all the training, all the tests that you can possibly imagine in the domain of environment. Okay, so I'm basically discussing with Dr. Richa and my other colleagues to find some time for all of you, those who are interested, to go and take a quick look of the lab and the facilities that we have, interact with our colleagues. We're also having a parallel training going by the lab team themselves, but we'll be more than happy to host you for a quick lab walk around. To talk about the solid waste program in CSE, you can see the numbers. So largely what we are finding out from the research is what we are feeding in the capacity building to support the ministry. I'd like to mention here that we are not paid by the ministry. So we are raising money with our donors to do whatever we doing these days. We have 2 aspirational cities like Agra and Gurugram, where they have a different plan. Where we're trying to engage with them, a little bit deep dive engagement you can call. And we are empaneled and enlisted as a center for excellence with 11 key institutions and ministries. So if I just give you a brief: Environment Ministry, Urban Ministry, Jal Shakti, Chemical Fertilizer, Agriculture, Farmer Welfare, Petroleum, Natural Gas, New and Renewable Energy, Rural Development, Panchayati Raj, Road Transport, Highway, Niti Aayog. So all this institution has strong presence in the domain of environment, and CSC has been actively associated with all these institutions in policy making, in dialogues, in consultations, discussions. In 2022, last year, between September and November, Honorable Prime Minister created an interministerial committee of 11 key ministries. All these institutions basically featured there to explore how more circularity can be instituted in the practices of urban and rural solid waste ecosystem. And I couldn't be happier to share with you that we have been advocating this for a long time. For heaven's sake, please impose landfill tax, to disincentivize dumping, and change the procurement system or change the concessionaire agreement pattern. Don't pay the concessionaire on the quantity of mixed waste, because you are the one who is deciding the terms of engagement, right? Being the local government. So make it segregation based, or create some other mechanism, right? Incentivize the citizens for segregation of home composting. So the mantra is very simple: incentivize segregation, disincentivize dumping. So we did a conclave, a national symposium, to release one of our report, authored by three of my colleagues, Mohsen Gupta, Kaifi Javed, and Kuldeep Chaudhary, about the current status of bulk waste generators, right? So bulk waste generators are the sources who are generating more than 100 kg per day. We don't even have an inventory, don't even know as a nation how many bulk waste generators do we have in 4,000 plus cities. And then we have a mandate from Solid Waste Management Rule 2016, coupled with CPHEO manual. CPHEO happens to be a technical arm under the ministry. So they released a comprehensive manual to elaborate the scope of the law. So, and we realized as a community that we are nowhere in terms of implementing it on the ground, right? So basically, we are trying to do whatever little we can contribute with as an institution, a responsible organization. So we have a very strong global presence. In the waste program or circular economy program, we are currently working with these many number of countries. And again, Dr. Richa is leading the entire engagement on behalf of CSC with all these countries. All of them visited this campus in the month of May for a 5-day training and exposure visit. That was the third event. We are trying to influence their policies. They are super impressed with whatever little they have seen. They know that India is a big country. There are a different set of challenges, right? So we are trying to constantly engage with them, build their capacity, influence their policy ecosystem, influence their implementation arrangement, institutional arrangement. And there are lots of promises that probably we'll be able to talk about. Down to earth happens to be our voice, our amplifiers, right? So when Anilji conceived CSC, he didn't have technical people, he didn't have the money to, start a big program. So he started with something like this. And today, Down to Earth has almost 40 lakh people reading every day, either in hard copies or soft copies. This 40 lakh also includes our global audience, right? Our website is visited by almost 20 million people every year. So you just divide 20 million by 365, you can calculate the average number of days. So we release 2 volumes of Down to Earth every month. As an alumni through this program, you will get a free subscription of next 12 months. One soft copy of Down to Earth will be delivered to your email address. It may take some 7 to 10 days time after this event is over. We also release an annual edition of Down to Earth every year. We call it a State of India's Environment. That was Anilji's dream. We lost him in 2002, but we continues his legacy. And a lot of students preparing for public service exams or engineering exams also refer to this. So that basically gives us a lot of satisfaction and a reason to kind of pursue these dreams. So last year we released this report here in this campus in presence of Honorable Union Environment Minister Mr. Bhupendra Yadav. About CSE, it's a green campus. Just I'll draw your attention in this left box on the top of the screen. So these are the reason why you call it a green campus, that we basically tried to walk the talk here. That, okay, when you are lecturing us about things that we should do, whether you're doing it yourself, yes, we are doing it ourselves, right? So some of the points that I would like to, so all the entire building, all the buildings that you can see are built on the principle of thermal comfort. So compared to any average building of its size, our energy requirement for heating and cooling is 30 to 40% lesser. Because the elevation are very simple. It's just a simple traditional concept. All buildings are north-south elevation. You won't find a single building with east-west elevation, which exposes it to the sunlight, right? And increases the energy consumption for heating and cooling. Our heating and cooling system itself, which is currently being used in this room, is also state-of-the-art system. It's called HVAC, which instead of using a gas-based, compressor-based technology, use water evaporation to kind of maintain a temperature between 24 to 27 degrees Celsius, which is the temperature that you want. Even if you are entering your home, turning the AC into full blast, 16, 17 degree, you can't sustain that temperature for more than 5 to 6 minutes. Eventually, you increase the temperature to exactly the temperature that you are feeling right now. Are you feeling uncomfortable, by the way? I hope not, right? So then it is just about being sensible, being sensitive to the energy that we are using to, you will find big buildings completely covered by glass, all sides, no ventilation, no aeration, nothing. Which the buildings are designed to kind of run air conditioner 24/7. Is it required? Right? So we are doing lots of research to propose that there should be a standard building code and it should be enforced. So the design of construction should not be left with the individual and institution who are building them. For an example, so we are treating our black water or gray water. So the water that you are using for flushing is nothing but treated gray water, which is coming back from a nature-based solution. Again, Asolekar sir is here. So we build these nature-based solutions with the help of IIT Mumbai. There are many more to talk about. Our solar energy is more than the energy that we need to run the air conditioning system, run the laboratory and other equipments. But we don't have storage because storage will cost us around 8 to 10 crore. So storage of the solar energy will cost us more than the price that we had to pay to buy those panels, the solar panels. That is how expensive it is. And currently we can't afford it. So whatever excess energy we have in the day, we sell it to the DISCOM in Rajasthan because we are in Rajasthan's territory. And then that energy we buy back in the evening at a subsidized cost, or you can say when we get the energy bill for whatever energy we consumed, we get a certain amount of discount for the energy that basically we are giving them during the daytime. So there are many stories to talk about. I hope we'll find time to talk about all of them. Context of the conclave is something that I have already explained in the morning, and I'll let Dr. Richa talk about the report, and she is the best person to take us through all these things. So the reason why we had to do this study, that we are losing a resource which is eventually causing global warming, causing pollution, which is much more potent than probably carbon dioxide as a gas, which could have been intercepted, captured, and used as a fuel. Now, where we are headed is the question that we are contemplating now. So I'll stop here. Please read this message carefully if you want. So we all need to kind of see the change in ourselves before we talk about it to others. Yes, sir. Quick question. Sir, can I just come back and explain it to you later? I'll explain to you later, I promise, over lunch. Dr. Richa, over to you. Please come over. So there's a lot more to talk about both ATI and CSE. So whosoever has any question, you can speak to us, you can write to us, whichever way. Yes.
Hello, good afternoon, everyone. I hope you're liking the campus and the sessions. Okay, so I'm here to talk about the key highlights of our report on methane emission from dump sites, open dump sites in India, and what are the estimation and mitigation strategies. What could be the possible mitigation strategies and estimation strategies? So in this presentation, we are going to talk about India waste sector contribution in overall GHG emission, how much methane is generated from waste dump sites, waste sector, process of methane generation from a landfill, a typical sanitary landfill and a dump site, unscientific dump site. What are the available methods for estimating methane emission from landfills and dump sites? We will talk little about the availability of data in India's waste management sector, which I think is a major limitations when we are trying to estimate the methane generation from dump sites. Mitigation measures for methane reduction from the waste sector and the current challenges followed by the recommendations. So stuck. Please excuse me for a minute. I think it's not going up. Maybe I'll just remove this one. No, but sometimes the slides are getting stuck because we are on. Can I use that? Hello. So going forward, so we'll talk about overall, what is the overall GHG emission from different sector, the sector-wise GHG emission, and this is compiled from the data available by MOEFCC in their third BUR report, which states that, as you can see in this pie chart, waste sector is contributing to around 3%, more precisely 2.7% in the overall GHG emissions coming from different sectors. And if I compare it with rest of the sectors, it is relatively lesser than rest of the sectors. But it is interesting to note that when we compare the growth of emissions from 1994 to 2016, waste sector is something that has witnessed maximum growth of 224% in comparison to rest of the sectors. Followed by that, there was energy sector, agriculture, industrial processes, and product use. And waste is something which is contributing less in terms of overall GHG emission. Here, we are not talking about methane only, but we are talking about all the greenhouse gases. And the relative growth from year 1994 to 2016. So now coming to methane emission from the waste sector, methane is a potent greenhouse gas, which is having a global warming potential of 20, which is 28 times more than that of carbon dioxide. The atmospheric concentration has more than doubled over the last 2 centuries, and this is a global data. It is a short-lived climate pollutant, which means that if you compare its atmospheric lifetime or lifespan, it is 12 years, which I think is a good news, because if we are doing something to mitigate methane or to kind of reduce the methane emissions, we are going to see the impact soon in comparison to carbon dioxide. So its atmospheric lifetime is 12 years, and which means that it traps huge amount of heat in the first decade, first 12 years, and then it will dissociate. When it reacts with ozone, it forms carbon dioxide and water. Again, the carbon dioxide will keep on heating the earth for another 100 years, like that. So it contributes to the formation of ground level ozone or tropospheric ozone, which is a pollutant, and exposure to which causes 1 million premature deaths every year globally. So if you see this pie chart here, you can see the waste sector is contributing to around 14% of the methane which is generated in the country. And this is again a data which is extracted from MOEFCC third BUR report. So these are the emissions, methane emissions given in gigagrams. So as you can see, even in the waste sector, it is dominated by wastewater treatment and discharge. So more than 3/4 of the total emissions in waste sector is contributed by wastewater treatment and discharge, which translate to around 78.9% of the total GHG emission in waste sector. And 21% is contributed by the waste disposal side. So we can say that out of the 2.7%, which was the total GHGs, which was contributed by waste, 21% of it was contributed by is contributed by the waste disposal sites or landfills or dump sites. So if we calculate that, it is coming out as 754 gigagrams of methane, and if we convert that into carbon dioxide equivalents, it will be 15,832 gigagrams carbon dioxide equivalent. So this is a trend, as you can see here, from 2011 to 2016, how the methane generation has increased. Now, how methane is generated in landfills and why it is a matter of concern. As you can see, this image is self-explanatory, and I have talked a lot about this at various platforms, that it is because in India, we are not dealing with scientific or sanitary landfills, which are constructed in scientific manner or operated in scientific manner. It's just a mere piece of land where waste is being disposed of. And this legacy waste it could be 10 years old, 20 years old, or up to 50 or more than that. And there is a series of biochemical reactions which is happening. And as a result of that, a lot of methane is produced. I see methane as a fuel, as something, and it suits very well with the definition of waste. Waste is something which is a resource, but if it is at the unwanted place, it's a waste. So same happens with methane. If you capture methane in controlled conditions, it follows the same reaction: hydrolysis, acetogenesis, and then methanogenesis. A lot of methane is produced. But if it is happening in a controlled condition in a biodigester plant, you can capture it and use it for gainful applications. But if it is happening here in uncontrolled conditions, a lot of methane is getting escaped. Now, so those who are working in bioremediation, legacy waste management sites, they know that there's a lot of so many other environmental long-term and short-term hazards associated with dump sites, including the leachate that it produces, including the dump site fires, odor, all sort of menace it causes. But methane is something, and I was glad to hear that from Shri Tiwari ji, who spoke about it, and he said methane is something which is a silent killer or silent polluter. Why? Because it is odorless. Why? Because it is colorless. Even if I'm inhaling it, I will not be able to realize that. So that pungent odor, that foul odor that we get when we pass through any dump site is because of the other pollutants. It could be the non-methane volatile organic compounds like formaldehydes, like acetone, benzene, etc. It could be ammonia, or it could be hydrogen sulfide. But in case of methane, if it is in pure form, you will not realize if you're inhaling methane or if it is there in the environment. But it is a potent greenhouse gas and climate pollutant. So what is the fundamental difference between engineered landfills and open dump sites is something that is extremely important for us to understand, because this also affects the quantity of methane which is generated by a dump site or a typical landfill site. So if you see what happens in a scientific landfill site, so scientific landfill site or sanitary landfills is it is a containment system which basically isolates your waste from the surrounding environment. So it is designed in such a way that it has all the barrier layers, including the HDPE liners, the leachate collection system. There is a proper mechanism for gas collection and utilization, etc. And it makes sure that minimum damage is happening to the environment. Whereas if we look at the dump sites that we have in our country, most of it is actually unscientifically designed. Most of it, or I would rather say all of it, is actually unscientific in nature, not constructed and operated in scientific manner. Many of the sites in our country are now having sanitary landfills, but the operations are not sustainable. So it's not that you have constructed a sanitary landfill and you leave it like that, and then you keep on dumping your waste. It will ultimately eventually become a dump site after some time. So you have to make sure that it is, it is being used in a progressive manner. There has to be a phase-wise, utilization of space in the sanitary landfill, which is not happening right now. So the issue is when we dump mixed waste. So in the morning also, Sunita ma'am was talking about source segregation, why it is important. The issue with our waste is most of it is being dumped in the dump sites in mixed form. And when it is disposed of in a mixed form and it reaches the dump site, the dump site starts acting as an ecosystem itself, where there is interaction between abiotic and biotic factors. There will be a series of biochemical reactions that I've already spoken about. And at the end of the day, what you get is a lot of pollution. It can be considered as a pollution hub, which is, you name one sort of pollution and you will find it here, be it land pollution, be it water pollution, groundwater pollution, surface water pollution, air pollution, all of that. And again, methane is something which has become a global issue. So this happens, the landfill gas generation, and what are the typical changes over time. You can see this in this graph. So basically it can be divided into 5 phases. In the phase 1, when there is plenty of oxygen available, when the waste is disposed of, it is consumed, and there is a aerobic conditions where the aerobic bacteria will be there, and they will, here the main end product will be your carbon dioxide and water. And once it ends, there will be anaerobic, the anaerobic phase will start. So again, in this phase, hydrolysis, acidogenesis, where a lot of organic acids are formed, like formic acid, lactic acid, etc. And some alcohols will be formed, like methanol, ethanol. In the next phase, once the anaerobic conditions will prevail, then this acetic acid will be converted into acetate. And in that kind of situation, or that kind of environment is very well suited for the growth of methanogens, or the methane producing bacteria. And as a result, as you can see here, in the first phase, this is representing nitrogen, because nitrogen is also an integral part of the, that constitute your biogas or your landfill gases. And here you can see methane. This is the unsteady methogenic phase, and then there is a steady methanogenic phase. Now, it is very important for us to understand that what all factors are there which affects the methane generation. The one is, of course, how the landfill is constructed. If it is unscientific, there is no mechanism for methane collection and treatment, then it will emit more methane because it will be happening in uncontrolled conditions. Even for sanitary landfills or scientifically designed landfill, if someone is claiming that it is a good solution for even for treating your organic waste, we don't buy that argument, because in many cases what we have seen is the potential of GHG recovery or landfill gas recovery from landfills, it ranges between 20 to 25%. Dr. Ashutosh, please correct me if I'm wrong. In fact, I believe that should be even less than that, 10 to 15%, just 10 to 15. It's really difficult to extract landfill gases even from a sanitary landfill site. So it's always advisable to treat your organic waste in biodigesters or through composting plant. Sir, do you have anything to say? We will discuss that. So it's very important that we don't go for that mixed waste dumping culture or mixed waste disposal, even if we have a scientifically constructed landfill sites. In fact, I have heard at many places that there is a sudden fire outbreak, which we are, we get to hear a lot about these cases in Delhi, in the national capital. Now, what to do? What could be the interim solution? And many people come with this solution that let us install some gas suction pipes in these landfill sites, and then maybe we can recover methane. We can remove methane, which acts as a primary fuel for landfill fire outbreaks, which I think is also not a good idea to do, because I have not seen a single place where fire can be extinguished in this way. In fact, the best way to do it, even if you have a unscientifically managed landfill site or a dump site, we need to make sure that we are putting the soil cover every day, daily soil cover at 10 centimeter thickness. And then we also need to compress the waste once it is received at the landfill area or the dump site. So now if we talk about what are the typical landfill gases, so whatever gas is generated from a landfill site or dump site is not 100% methane. In fact, that holds true for biomethanation also. So that is called biogas, and here we are calling it landfill gas, but the composition is more or less the same. So in this case, the methane concentration is around 45 to 60%. Carbon dioxide is 40 to 60%. So primarily, there are two gases which constitute the GHG emission coming out from a landfill site, which is methane and carbon dioxide. Then we have nitrogen, oxygen, ammonia, non-methane organic compounds, sulfides, hydrogen, and carbon monoxide. But this composition could be different in our case because this is the one which is given by US EPA, considering the landfill sites in US and also the waste composition and biodegradable fraction in US conditions. It is not suitable. I don't think the time that is considered, like 5 years is the time which is given by Shubhano Gloss in the US, that this is the time frame when you will get peak methane emission. It could be different in our case because we are having different climatic conditions, and at the same time our waste composition is also very, very different from the US and the Western world. Now, what are the factors? The first is composition and age of the waste. The fresh biodegradables will produce more methane than legacy waste. Now, this is also a very, typically we are asked that why we are doing legacy waste mining, because there is no methane coming out from the legacy waste. But we need to understand that the sites that we are dealing right now, most of them are still operational in nature. So we can't say that this site is having waste which is 10-year-old waste. This site is having waste which is 20 years old or 50 years old. So methane recovery or methane potential is not there in the waste because those are still operational. And biodegradation is a process which can, it goes on for years. And same holds true for methane emission also. The first 5 years will be the time when the emission will be on the higher side. And then eventually it will get steady, as we have seen in the previous graph. Then pH of the waste is also something that affects the generation of methane gas. So it is most of the researchers, what they have suggested that 6.8 to 7.4, if the pH is in between in this range, there will be high methane generation. Moisture content, the optimum moisture content should be 38.8%, which is optimum for methane generation. Moisture is also very, very essential for biodegradation to happen. Now, again, I would like to talk about the bioreactor landfill sites, which has been promoted at many places, even in India. In fact, I've seen one in Kanjurmarg. But bioreactor landfills, again, is not a good idea for Indian scenario. Why? Because our waste is already having a lot of biodegradable organics, and that's why it has more than 38.8% of moisture content for sure, which is ideal for biodegradation to happen at a stipulated time. Temperature, it should be 30 to 40 degrees Celsius. However, an increase in 10 degrees Celsius doubles the microbial activity, which we have already seen during summers. The cases of, fire outbreaks will be on the higher side. Why? Because there will be more degradation happening because of the high temperatures. It can go up to 40 to 45 degrees Celsius. And if I compare the methane concentration in ambient air versus what is the typical concentration in a dump site area during summers. So in ambient air, we know that this present in traces, which is 0.00017% by volume, right? But in a typical dump site area, it might range from 3% to 15% during summers, which is, again, very, very problematic because a small, tiny source of ignitable materials can cause fire outbreaks. Seasonal variation, again, during summers, there will be high methane generation followed by monsoon and then winters. Presence of complex biomolecules. So what we have seen is certain kind of biomolecules containing lignin, cellulose, or biomolecules which are difficult to biodegrade. Will take a lot of time for their complete decomposition, and the methane generation will also be drastically affected by this, by the presence of complex biomolecules. Some of the biomolecules are considered as recalcitrant, which means that they will be like that. I mean, they will not degrade for many years, and which is also a very problematic thing when we are talking about getting rid of all the legacy waste, because some of it is actually not possible to biodegrade very easily. Available methods of estimating methane. from landfills and dump sites. There's so many methods. So if I have to broadly classify the methods of estimating, there are two methods. First is theoretical methods by using some sort of models, which is the most adopted one. And then we have experimental methods where we just go to the site, try to see how much is methane generation. So most of the time the researchers are adopting theoretical methods. In fact, the study done for India's third BUR report is done by CSR NERI, and we have Dr. Sunil Kumar who will talk about it. But they have also adopted the first order decay method, which is the most universally accepted method for doing it. And I think CSR NERI was the first one to came up with a model called modified triangular model back in 2000. It was year 2000 or 1999, I don't remember exactly, but this was the first, when the first NOTCOM report for MOFCC was prepared. It was prepared by CSR NERI, and they adopted the modified triangular method. Now, what is the problem with all these models? And what is the input data? So we know that for any model, we need to have very good input data. When I say very good input data, I mean to say that I need to have data which is based on ground reality. So the first thing I would need is, what is the current generation of waste in my country? Is something that, so Professor Sulekar showed you what should be the quantity of waste in 2020 in India. And if you will follow business as usual case, how much will be the quantity of waste by 2050 and like that. But if you see the data which is available in CPCB annual reports and also in SBM Urban, the first report that came in I think 2014 by the Planning Commission, it reported that in 2014, the municipal solid waste generated by the urban India was around 62 million tons. And for some reason, I assume that every year it should increase a little bit, but it is reducing. So now if you ask me how much is the municipal solid waste generation in 2020, it is 55 million tons. So basically, the data is not so credible and inconsistent. So in order to make a correct estimation, first of all, we need to know how much is the waste generation in the country. We also need to know how much of this waste is actually biodegradable in nature, because only that part is going to degrade and produce methane. Right? That also, we are taking a national average of 50%, which I don't think is very correct because it is changing everywhere. So if we want to do a pan-India study, we should categorize, urban India into different economic groups or maybe different class of cities and do the analysis based on the real ground data. Like we need to do the sampling and see how much is actually biodegradable organics, how much is non-biodegradable organics, and estimation should be based on that. The other thing is, every fraction of biodegradable waste will have its own rate of decomposition. In our biodegradable waste, we are also dumping the garden waste, which will take more time to degrade, whose methane emission potential will be different than the normal food waste. Right, so those are the things which are not considered in these models in Indian scenario, and that is why it's really difficult to say that these models are precise or accurate, and there's a lot of variation also. So if you see studies or estimates which are done by different research institutes and academia. And I think the second panel's discussion, we will get to hear a lot about it from the experts. But the same problem lies, like there is a lot of variation. Even if there are 3-4 researchers who are using the same model for estimating methane in India, they will come up with different values. Why? Because the assumptions are very different and they are not based on the ground data. So the most simplest one is the IPCC 1996 default method, which is based on mass balance approach. And in this case, time is something that is not considered. So it is, if you apply this model, it is basically, it will tell you that this much quantity of biodegradable waste will produce this much methane in gigagrams, but it will not consider that these many years will be, taken for complete biodegradation. So if I have to compare, I think land gem is something which is the most accepted one universally, and people are using, it is again developed by US EPA, and we are not sure if the default values are correct in Indian scenario and if their considerations are correct in Indian scenario. So limitations, unrealistic assumptions will give overestimated results if we are using the conventional IPCC 1996 default method. So in modified triangular method, parameters are dependent on DM default values. Data availability is something which is a big issue. IPCC 2006 first FOD method, since it considers parameters of temperature and precipitation, wide range of data availability makes it uncertain. Often there is lack of historic data. So in this case, if I want to see how much methane is generated from Ghazipur dump site in Delhi, I have to consider a base year. Let's say I will consider that from 1970 till 2000, in the span of 30 years, how much methane would have been emitted by this landfill site. And for that, I would need data, each year's data of waste going to the Ghazipur landfill site. Now we don't know how much waste is, it's very problematic because we don't have records about how much waste has been disposed of in each of the landfill sites in our country. Why there is variation in methane estimates? As I already mentioned, default values in the models are not updated. The decay rate is assumed to be constant over time. However, it can vary depending on the temperature and moisture content in the landfill site or a dump site. Variation in waste composition due to activity of informal sector, which is not considered in all the models, because all the models are basically developed by the US. So land gem is something which is being adopted majorly by all the researchers across the globe, and this is developed by US EPA, and same holds true for sweet model also. Accidental fires in dump sites are not accounted for in estimates. Unavailability of credible ground data, I think this is something which I think is the most important input data that we should have in order to make proper, precise estimates for methane. Now coming to the unavailability of data, or why this is inconsistent. So if you look at the quantum of waste which is generated in our country per day by urban India is 1.6 lakhs tons per day. Now this is as per the Central Pollution Control Board annual report, the most recent one published in 2020-2021, which says that around 2.5% of the total waste remains uncollected out of this total waste, which translates to around 7,200 tons per day. Then out of this, around 50% gets processed and treated, which is 80,000 tons per day. Around 18% is getting landfill, or I would rather say it is getting dumped in dump sites, which is 29,440. And we have no data what is happening. So if you sum up all these three and subtract this from 1.6 lakhs tons, this is something is the gap. So even if somebody is saying, I'm so sorry to say this, Dr. Kumar and Ashutosh ji, like we are not accounting this much waste, which is 43,360. Or maybe if the estimates are based on what is a per capita generation, and then you are multiplying that with the population of urban, I don't know what researchers are doing, but those assumptions are also not written in the scientific articles. And that is why it is really difficult to understand that, if the estimates are correct or precise or close to the what we can get, because around 27.1% of the total waste remains unattended, unidentified, and we have no data about what is happening to it. So this is the gaps in the waste data per year. This is also reported by the Central Pollution Control Board annual reports, where you can see that for the year 2020, 2021, it is 32%. Why it is 32%? Because around 27% was uncollected, unidentified, and then 4.5 remains uncollected. Now, talking about waste processed versus landfill in India or dump in India, if we see there is a lot of discrepancy in the data. For instance, I'll just take an example of West Bengal. Can you see here? This is the quantity of waste processed. It's very less. And if I compare it with the quantity of waste which is going to the landfills, this is again, so where the waste is going, we don't know. This is it is somewhere here, yes. So there could be two conditions. Either the waste is getting treated or it is landfill. So there is a lot of discrepancy if we look at the data availability in our country, which makes the estimates even more unrealistic. Then again, there is discrepancy in number of dump sites in India. So if we look at the CPCB annual reports 2020, 2021, we have to deal with 3,179 dump sites. And if you browse through SBM Urban dashboard, you will see only 23 dump sites. And they say that only such dump sites are reflected there, which has more than 1,000 kg. 1,000 kg, it's not 1,000 tons of waste. So it doesn't make any sense, because 1,000 kg is nothing to be called as a dump site. So I'll talk about Uttar Pradesh, from where I come from. You can see huge discrepancy. It was earlier reported that there are 611 dump sites in the state. Now it is showing 187 dump sites in the SBM Urban dashboard, which is a matter of concern. Or maybe they have already remediated, but that data needs to be there in the public domain. So research on Delhi dump sites, this is something which is the most, researched topic in most of the academic institutes and university. And why I'm showing this, because this, you see, you will not be able to match any one of these values. So if somebody asks me, what is the methane emission from Ghazipur landfill, I'll not be able to tell you, because I don't know which one I should rely on. So again, the reason, the uncertainties and variation in methane estimates, default values are not updated, variation in waste composition, I think we already talked about it. There has been research on methane emission from landfills in India using different models, and a lot of it has been documented in my report, which you can refer to. But again, there is problem of, I don't know if these values are validated, if these models are validated. Some people have done in situ measurements, but again, that is also questionable, because there is no on-site monitoring or measurement happening in the country. There is one study being done on Kanjurmarg and Ghazipur. Kanjurmarg is in Mumbai, and Ghazipur Delhi landfills in 2020 and 2021, where they did it by using satellites imaging, and they actually found that the quantity, by seeing these, you can see these plumes, and they reported that the quantity of methane emission is 5 to 10 times more than that of the predicted by the models that we use, like LandGEM or FOD, first order decay method. However, there are certain limitations when it comes to research on methane emission from landfills in India using satellites. First of all, satellite-based methane estimation is of course a powerful tool, but one of the major limitation is there is a need for frequent satellite surpasses, challenge in differentiating between methane sources, and difficulties in capturing methane from small and dispersed sources. So even if there is a biodigester plant, so very recently I came across this news in Argentina and Spain, they could actually see some plumes of, and they called it as high emission sites. So, and they observed that there is no dump sites around it. But why are we seeing a lot of methane plume over there? It was because there was fugitive methane emissions coming out from the biodigester plant. So that is also something that maybe we have to monitor. So methane is not something that we have to monitor only at the landfill sites or dump sites, but we need to monitor this even in the waste treatment facilities, especially the biomethanation plants. So what would be the mitigation measures? I think we already talked about it, and we have heard a lot about it from Professor Solekar, from Sunita ma'am, and from Atin. I think there are two approaches. There are two preventive, and these are not the things that one should do to, methane abhi environment pe ho gaya, how to deal with that. These are the preventive methods, like measures that one should go for. First is remediation of old legacy waste dump sites. And then the scientific treatment of fresh municipal solid waste, especially the biodegradables. Remediation of old legacy waste dump sites is one of the major mandate given by Swachh Bharat Mission 2.0, which is where the vision is to make this country garbage free by making sure that whatever fresh waste is generated on a day-to-day basis should be treated by adopting circular economy principles, by adopting source segregation, and only 80% to 15 to 20% of the waste should ideally reach to the sanitary landfill sites. And the other thing, most importantly, is to get rid of all the existing dump sites, where I see it as a, the long-term vision of this is to make this country free from this culture of mixed waste dumping. Which I think is extremely important. Right now, we are only thinking about how to do that, how to get rid of the legacy waste and reclaim the land. But actually, we are not thinking about the other issue, that how do we deal with the fresh waste? We should not be creating more landfill sites for our future generation. The concept is very clear here, which was also mentioned by Sunita ma'am in the morning. So this is the mitigation strategies. The pre-land disposal, of course, food waste, generated from the household is a major source of methane coming out from the landfills or the dump sites. And as waste generators, what we can do at pre-land disposal space is to prevent food losses and reuse it as a cattle feed. This is also mentioned in the pyramid which is proposed by the Mahua Ministry of Housing and Urban Affairs pyramid for integrated solid waste management, where they talked about reused in the beginning, followed by that once the waste is generated should be recycled by adopting appropriate technologies like composting in decentralized manner or biomethanation. Once the waste is, so of course, there is a lot of around 160 million tons. So again, it's an underestimated value, but it's given by the government. So we have to go with that. So even if we have to deal with 160 million tons of legacy waste, we need to understand that it is a mix of all sort of organic waste, including the waste which is completely degraded, waste which is partially degraded, and the waste which is undecomposed or recently disposed of at the site. So that needs to be treated, and I think we have already talked about it, how the legacy waste remediation is happening in the country, and we have with us representatives from Resustainability and Sigma who will talk more about it. But again, this, if you ask me, this is also something which involves a lot of machinery, equipments, etc. And this will also release some sort of carbon, or greenhouse gases. The answer is yes, it will. But here, the major culprit is methane, and methane has a global warming potential of 28 times more than that of carbon dioxide. So maybe if we do the cost benefit analysis, and if we calculate the avoided cost, by bioremediation, it will be much more than the emissions that the bioremediation projects are causing right now. So methane reduction by organic waste treatment. So I'll give you one example of bio-CNG production by using municipal solid waste. As you can see, The potential is 2,386.7 tons per day. And right now, what is the current generation? It is just 47 tons per day. So we can produce, since you were asking about what to do with Delhi's waste, it is generated in humongous volumes. It's 11,500 tons per day. But 50% to 60% of it is actually biodegradable. And if we look at the Indore model, where 550 tons of organic waste is converted into 17,000 kgs of or 17 tons of bio-CNG every day. Imagine Delhi is having huge problem. We are having compromised air quality, and CNG cost is very high. Imagine that if we are treating that much around, if I consider that as 6,000 or 5,500 tons of biodegradable waste, if we are subjecting it to decentralized bio-CNG plant, how much bio-CNG we can actually get. But for this also, it's very important that we get source segregated waste, because the success of any technological intervention, it depends on the quality of feedstock. How is the waste? Is it in segregated form or not? If it is, the segregation level is not more than 90%, it should not be subjected to biomethanation or bio-CNG plant, because it will fail the plant. The same happens with waste to energy plant, which follows thermal decomposition also. If the quality of feedstock is not right, if the moisture content is high, if the organic content is high, that plant would not be sustainable. So these are some of the states where we have plants for organic waste processing and converting it into bio-CNG, including Madhya Pradesh, Andhra Pradesh, Karnataka, Tamil Nadu, and Maharashtra. Now coming to methane reduction by dump site remediation. So I would say this is the avoided methane emission, from the interventions like landfill mining or biomining. There are three approaches which can be used for remediation of existing dump sites that we have in our country, including biomining, biocapping, and hybrid model. Biomining is something which is the most adopted and most preferred method recommended by MoA as well as various NGT orders, where the entire waste is treated, entire land is reclaimed, entire waste fractions are used for gainful applications. However, practically many cities are struggling to get rid of the segregated combustible fraction, what to do with it. Then there are other environmental concerns, including the recovered fractions. What if it is contaminated with toxins? What if it is having some sort of phytotoxicity? What is going to be the end use of those recovered fractions? What to do with the land once it is recovered are some of the things that one need to consider. This is the steps involved in biomining of legacy waste. It is a systematic process of excavating the waste, converting it into equal size windrows, spraying some bioinoculum so that you get a stable mix of waste, and then subjecting it to size segregation equipment so that the combustibles will be segregated from the fine soil-like material or CNT waste, etc. This is how it looks like. So the first step is your waste is, the dump site is converted into equal size windrows. Then it is the bioinoculum is sprayed over it. Then typically we use trommel machines to do the size segregation. In bigger dump sites where we are using mobile sorting machines because it has more efficiency, and also the quantity of waste that one can treat will get enhanced. So these are the different fractions that you get from your legacy waste dump site remediation mining. What are the challenges? I think we already talked about it. There is gaps in data and preliminary planning, incorrect estimation of legacy waste quantum, gainful utilization and disposal of recovered fraction is very, very challenging. Absence of clear standard for recovered waste. So how do I say, suppose if I get fine soil-like material, how do I say that this particular fraction of waste can be used for horticultural purposes or as a filler material for the low-lying areas, because still we don't have any standards for testing our soil. We do have standards for agricultural soil, but we don't have any standards as of now for soil testing. Lack of availability of sanitary landfill sites and lack of capacity to operate a sanitary landfill. I would rather say this is extremely important. Government has allocated a lot of money under the Swachh Bharat Mission 2.0 mission, where funds are available for constructing sanitary landfill sites. But how do we operate it? Something is something that is missing. Carbon credits and other financial incentives for promoting remediation. So this is something that I would like to know from the speakers also, if we can make it more lucrative in terms of revenue generation. So carbon credits, because again, it's a avoided methane emission. So there is an established protocol also, which you can see in my report. And I have seen one project, which is in Kullu Manali, has claimed carbon credits by bioremediation. And I don't know how successful is that, but that has been mentioned in the standards also, that one can get carbon credits by remediating the sites or the old legacy waste dump sites, because it's a potential source of methane. Challenges and recommendation. Firstly, phase out the disposal of biodegradable waste in landfills is the first recommendation. From our side, developing new or strengthening the already existing policies governing management of biodegradable waste can incentivize its diversion through source segregation. We have a law called Solid Waste Management. Yeah. No, if you refer to, under the responsibilities of urban local bodies, it is mentioned that by the time you install the recycling facility for treating your organic waste and non-biodegradable waste, you can still dump your mixed waste to the landfills. So so that is why we are saying that we need to strengthen the policy, sir. If you don't have the policy, it's given as 3 years from the date of notification of the law. But this is very, very important. If you put that, that loophole in the law, then it becomes really difficult for the ULBs or anyone else to. Otherwise, people would say that landfill is also a very good option for recovering methane from, waste. Yeah. So there is a problem with implementation and enforcement, sir. Yeah. So but if you don't have a policy, you will not be able to enforce and implement it. So this is the first thing. And that is why I have mentioned we need to strengthen the policy in order to make sure that, there is no mixed waste dumping in the dump site. It's something that the data for quantity of MSW produced, its composition and quantity of waste disposed in landfills is highly unreliable and inconsistent. We have already talked about it, which makes the estimation very difficult and unreliable. A pan-India study needs to be conducted on estimation of methane and other GHGs from each of the legacy waste dump sites. And this will also help you to see if we can earn carbon credits. If we know the exact, not the exact, but precise estimates of methane that you are being able to reduce by remediating the sites, we can actually go for earning carbon credits out of it. Then in order to successfully expand organic processing pan-India, it is crucial to take into account both the demand from end users and the capacity to utilize the products and commodities generated, such as biogas-based natural gas, compost, and electricity. So there should be a win-win situation created for all the stakeholders involved. There has to be a market for the recyclable products that we are generating by using the organic waste. Carbon credits for biomining projects should be promoted. Till today, only one dump site remediation project in Kullu Manali has claimed carbon credits for their bioremediation project. mandate is needed to estimate the methane potential from already capped landfill or landfill sites or dump sites. I think we already have a mandate on this. Like we need to monitor methane gas in even a closed landfills, but that I have not seen a single landfill site where this has been done. What to do with the reclaimed land is a big question. I think afforestation should be promoted in the reclaimed bioremediated land, which is recovered after biomining of legacy waste dump sites, because it can act as a carbon sequester. So that's all from my side. If you want to read more about it, you can refer to the report. Thank you so much.
Okay, it's not as bad as I thought earlier. So we are supposed to break for lunch at 1:20. It's just slightly 10-15 minutes over. So we'll break for lunch now. But we have to cut short the lunch by about 5 to 10 minutes so that we can start exactly at 2:30. Here, is that fine, Richa?
Yes.
So, and we have a lot of panelists who has late evening flights, so we have to be on time. So I'll request all of us you to come back after lunch and assemble here by 2:30. Thank you.